In section 5.1, we're going to be learning about systems of linear equations and their solutions. All equations in the form of ax plus by equals to c are straight lines when graphed. Two equations are called systems of linear equations. A solution to a system of linear equations in two variables is an ordered pair that satisfies both equations in the system. So let's look at this first example. Determine if the ordered pair is a solution of the system. Now, these two are lines. This is a point. Our question is, does this point lie on both of these lines? In other words, when these two lines intersect, do they intersect at this point? That's the question. Okay, so in order for it to be a solution, this point has to be on both of these lines. So the way we will determine if this point is on both of these lines is we will take one line at a time. In an ordered pair, this is x, this is y. So let's look at this first line. Does the line x plus 2y equal to 2, does it contain this point? To determine if a line contains a point, plug in x is 4 into the equation, plus 2 times, plug in y is negative 1. So see, I replaced x with 4 and y with negative 2. Now we want to see, does the left side of this equation equal the right side? So I have 4 plus 2 times negative 1 is negative 2 equals to 2. Continue working on the left side. 4 plus negative 2 is 2. Since 2 equals to 2, yes, this is true. The point is on this line. Now let's see if the point is also on this line. So take x minus 2y equals to 6. And let's plug in. X is 4 minus 2 times y is negative 1 equals to 6. I want to see, does the left side equal the right side? So 4 minus 2 times negative 1, well, negative 2 times negative 1 is positive 2. So I have 4 plus 2 equals to 6. 4 plus 2 is 6 equals to 6. So that now that the left side equals the right side, then yes, this point is on this line. Now, in order for a point to be a solution, it has to be true for both. So if one was true and one was false, this point would not be on both of the lines. So the point would not be the intersection of the two lines. So therefore, in order for this answer to be correct, both of these have to be true. So yes, this is the solution of these two lines. This would be the point where these two lines would intersect if they were graphed. Now let's look at the next example. Is this point a solution of these two lines? Well, let's try it. The negative 4 is x, y is positive 3. So plugging it into the first line, x plus 2y equals to 2. Let's see if this point is on this line. So I have x is negative 4 plus 2 times y is 3 equals to 2. Negative 4 plus 6 equals 2, and 2 equals to 2. So yes, this point is on this first line. Let's see if this point is also on the second line. Plugging it into x minus 2y equals to 6. Plugging in x is negative 4 minus 2 times y is 3. Does that equal to 6? Well, that's negative 4 minus 2 times 3 would be minus 6 equals to 6. Negative 4 and negative 6 is negative 10 equals to 6. Those do not equal. Therefore, this is a no. Therefore, the answer to this problem would be no. This point is not a solution to this systems of equations. So in order for it to be a solution, you have to have Yes on both of these, or this point is not a solution to the system of equations.